So let me share my screen. You can see my screen?
Yes, ma'am.
I don't know if you'll be able to see it when I make it full screen. Let me try that. Can still see it?
Yes, ma'am.
Okay. So
No,
last
it's
time
not visible now.
was not visible?
No.
Screen is not visible.
No.
Now
Visible है मैम.
full screen mein maybe it's not working. Huh? Let me just leave it like this.
Yes, ma'am,
Now,
it's working. Sorry. Yeah.
so let me just leave it. Let's not do full screen. So this is fine. So last time we were talking about the setup. That's where I think we stopped. So so we talked about how generally EEG setup is put together. So we talked about there's a cap. There are wires connecting the cap electrode to amplifiers, and then amplifiers typically connected to a battery pack, which like these, both of these, we have two amplifiers each for 32 channels. It goes to an adapter. So the adapter digitizes the signal from the amplifier and moves it to the recording PC. And simultaneously, if there's a stimulus presentation that's happening in terms of pictures or sound or whatever, when you're doing a ERP type of study, that will also go in as a digital signal. And along with the EEG, the exact moment when the signal was given, that will get recorded. So this is an actual picture. This is very similar to the one we have at IIT. So here is the recording PC. Instead of PC, we have a laptop. There is a cap which has a few electrodes, and there are caps which have the electrodes fixed in them, and there are caps where you have flexibility to, put as many electrodes as you want, or you could just put the electrodes on people's face directly. So the cap, and then there's an electrode box that would go in there. Again, there's an adapter in which it's getting digitized. So which is probably not visible here. So this is the amplifier, and then there'll be an adapter which will go to the computer. There is a stimulus presentation PC where the stimulus will be presented, and along with the EEG signal that will also get inside the computer, so you can see it.
Usually,
Now,
ma'am, we have just one laptop, I think.
yeah, so if you don't need a stimulus presentation, if you don't need to do ERP study, you don't need this. This is optional.
Okay. And
This
this
is to send.
amplifier also looks different what we have.
Yeah, this is different, but generally, like, it can be various kind, right? But it is
Yeah.
basically an amplifier. This is a dual thing. It's a power bank plus amplifier type of thing.
Yes.
Okay, so now there is a concept of, this is something that you may not have heard, something called active and passive
Yes.
electrode. There are two types of electrodes. So what happens is when you have the electrodes stuck on the brain, it's picking up signal from everywhere. It's picking up signal from monitor, the other computer sources. It's picking up signal from the line noise, which is the electricity at 50 hertz. So what happens is in active electrodes, in the electrode itself, there is an amplifier. So the moment the signal is coming from the brain to the electrode, in between it is amplified. So it is a very nice way to reduce contamination from these extra ambient electrical noise, but it is also typically more expensive. But it's good to know that those kinds of systems also exist. The amplifier is attached in the electrode. So in those systems, you will see less of the power noise, less of the ambient noise, but it is more expensive. Passive electrodes, like we described, the electrode is there and there's an amplifier which is separate from the electrode. Electrode is just a metal disc typically. The older electrodes used to be a single metal disc, and the newer ones have these kinds of rings from different alloy metals, etc. But these are passive electrodes. But the nomenclature is little confusing. So, or you might have heard of something called reference electrode, ground electrode. Suna hai?
Yes, ma'am. Ma'am, passive electrodes we have, right? There. That's why
So
we
we
use
have,
gel.
what we have is passive electrodes. What Shilpi had was also passive electrodes. But in terms of, there's another confusing nomenclature, but do remember that when we have these kinds of montages,
Yes, ma'am.
these kinds of monitors. Other than ground and reference, most of the other electrodes also be called active electrodes, even if they are passive.
Okay.
Non-ground and non-reference passive electrodes are called active because they're in active brain regions. That's why. But
Okay.
the nature of the electrode, you have to know that it's active or passive. It is active because there's an amplifier within the electrode. So just know that when Rahul talks about the impedances, he talks about, active electrode में कम होता
Yes,
है
ma'am.
impedance, passive में ज़्यादा होता है. So you have to understand what he means then, like as a hardware, what he means, and then later on, even within passive electrode, there's ground, there is reference, and there's active.
Okay, within passive also.
Within passive. So now coming to reference electrode. Okay, so reference
Ma'am,
electrode
the generally we can understand like whenever we use any conducting gel or conducting paste something, so they are passive electrodes, right?
generally, and it will be very clear. The electrodes will look very complicated, when they are active, you'll
Okay.
have some kind of
Like in
light in there.
the one the Shilpi ma'am has used, they haven't used any gel or something paste, but still you are saying they are passive.
They are a band-like thing. This is a
Yeah,
different kind of, they're
like
inside a band, this kind of. I don't
yeah.
know. I have to check. Maybe they are active, but it didn't look like that to me, but I'm not sure. Okay, I'm not sure if there's an
Okay.
amplifier there. Maybe there is, I'm not sure. Just check. Shilpi can check and let us know. Um, So now coming to something called reference electrode. Have we heard of that?
Yes, ma'am.
Yeah. Shilpi, you've heard of that?
Yes, ma'am.
So in your band, at least the picture that I found, there seem to be three reference electrodes, not one. But also in the paper you shared, it said reference channel was FPZ. So I'm not sure which one is true, but you have to check and let us know. If there were three reference sensors or just one. But reference electrode is very important. So when we are doing EEG measurements, what we are measuring is something called potential difference. So potential difference is best explained by understanding pressure. When you have pressure difference, water flows, right? So something like that, there's potential difference and electrons will flow. So whenever you do differences, you need two places. You will measure the difference between either two electrodes on the brain, or one of the electrodes is generally in a non very busy area of the brain. So typically around the ear or something. That's a common way of identifying or using a reference electrode. So what you're measuring is the difference between the potential difference between these two electrodes, one reference and one electrode in the brain. If you had only two, if you had several electrodes, the difference is between any of these electrodes and the reference. So there's a fixed reference. Okay. So that is very, very important. Bipolar, so there's bipolar and monopolar, just nomenclature. In bipolar, what happens is one active area electrode is the difference is between electrode in one active area to another active area electrode. So both are active, both are getting brain signal, and we are taking differences. And in monopolar, you'll take a electrode which is in a very weird area, which is not exactly in active brain region, maybe below the earlobe, and then it's called monopolar recording. And then the difference is taken between all these electrodes to this. That's the difference. So
Okay.
if you
So
didn't
we
have a
have,
ground,
I think we use this monopolar, right, ma'am?
yeah, I think so. You can also check with Rahul or Nitesh where
Because
are
I tried to see that it was like the single FPZ, like single, it was mentioned. Otherwise, it
yeah.
should be double if it is bipolar.
Yeah, and there are weird caps in which there's difference between these two, then there's difference between these two, and several different types of bipolar systematic differences. So what we use is single reference, and the differences between one electrode and a single reference. So what happens if you don't have a ground? We also have ground. Shilpi's thing didn't have a ground. So when we
Okay.
when we have we don't have a ground, the what you're measuring in terms of signal is basically reading from any electrode I, let's say it's anywhere in the brain, I, minus signal from the reference electrode, and there'll be some noise that you're catching. And this signal is basically getting amplified and getting read. So this you need to remember कि हम जब measurements कर रहे हैं, what is it that we are measuring? Why do you need a reference? So you're taking difference between one electrode with another, We are not talking about absolute signal in any which way. And then we are taking the difference, and that difference is what we are measuring. And for all these electrodes, you're taking the difference between ground and this.
So reference electrode is basically to take a difference, right?
Yeah. It is to take the difference. Whenever we talk about voltage, we talk about difference. We don't talk about a single pole. We talk about difference between two things. When we talk about a battery, we'll talk about ऊपर और नीचे में क्या voltage difference है, right? Something like that.
And there is a
So
fixed position where we put this reference electrode.
yeah, ideally. In some cases, there could be differences, but for our cases, our reference would be one single place, and every electrode is taking reference from that same particular electrode. Okay. Now, you know that in electrical systems, we do grounding, right? There's
Yes,
a
ma'am.
ground ka concept. We take one particular socket and
Yes,
we
ma'am.
put it in the ground. So in EEG systems also, in more sophisticated systems, you will have a ground along with the active and reference. So all of these are called active, even if it's a passive electrode type. Active electrodes, reference electrodes, and you'll also have something called a ground electrode, which is also very important. It is for safety and it also
Okay.
suppresses noise. Okay, so now moving to
Because
ground. So
generally that ground in electric socket, that is for to prevent ourselves
yeah.
from the shocks.
So,
That's why.
so here we do it for several reasons. It's also for safety. It is good for safety. So that's also why we do it. But there is another reason. It suppresses noise better.
But
So
we do not
here what
have the
happens,
ground, I think, ma'am.
we have ground. We have both reference and ground.
Okay.
CZ में होता है generally बीच में यहाँ पे.
Okay.
So when you have a ground along with active and reference, then your signal becomes, you take a reading from one electrode, uh, subtract the ground from it, and there's some noise. And then you subtract reference minus ground from it. Okay, so instead of EI minus EREF, we subtract ground from both of them first. So that kind of takes care of noise element better. But mathematically, you can see this get cancelled out and it becomes EI minus EREF. So it doesn't, the position of the ground actually doesn't matter that well, that much. But it is good to have it because in both of when you're doing this subtraction and this subtraction, it kind of reduces the noise.
What is
So
SI, ma'am? It is signal.
signal, yeah, signal from
Okay.
any electrode I. So if you didn't have a ground, this is what your formula was. SI is EI minus EREF plus noise. And here you have EI minus E ground plus noise, then minus EREF minus E ground plus noise. And these two noises will be different, which is why you do it. And then these can get cancelled out. But because you're already subtracting it from both reference and ith reading, it kind of suppresses the noise. So it is good. But in some cases, people basically use the ground as the reference itself. So that's how, I think that's how typically in the bands, even in the heart rate sensor, we'll have both ground and reference as the same thing. They will be short circuited to each other, and then the
Okay.
other thing will take the reading. So everywhere you need a difference. But ground, generally, if you have systems which also has a separate ground, it is better, more sophisticated. Um, okay, so and this is a simplistic representation because none of us are electrical engineer. I'm sure there's more sophisticated circuitry that goes inside, but you can broadly understand that whatever electrode readings we are doing, we're subtracting ground from it. And whatever reference we are taking, we are subtracting ground from that. And then we are subtracting these two from each other to get the signal for one particular electrode.
Okay. So this whole process is going on behind. Actually, we are
Yeah.
not aware about it.
Yeah, we are not aware where it's happening. It is happening, but it is happening somewhere in the uh,
So I think
probably
it's not worthy to understand it because we are getting
you
actually
don't
what
have
we
to.
want.
Ideally, if you want to think about it, it will happen before you amplify the signal. So
Okay.
that before we amplify, we are doing this so that what we are catching is something, with already removes the noise a little bit more. Because in both sources, you will have noise, right? In reference also, you'll have noise. And in I also, you'll have noise. And we've reduced that a little bit by taking the differences. So it's good to know because you'll also do setups and you need to understand what your setup is
But
like.
still, we cannot avoid noise completely. That's why we always say that there are no, we have to keep actually keep an eye on that
Yeah.
signals.
Yeah. You can't completely avoid it, but these types of things sort of reduce it. So there's a lot of
Okay.
research that goes on into designing these circuits and how to make it better, etc. Like if you want to read more, you can have given sources. Um, so okay, so we understand ground is for suppression of the noise and also safety and several other reasons. So we just know that. Now this is the part we are all familiar with, right? So electrode
No,
placement. Now
not
we have a
familiar.
ground. Typically at the center of the head, we will have a ground. Somewhere
Okay.
here near the earlobe, which is not a very active region of the brain, we will have a reference. And rest of the electrodes are placed in systematic manner. So if we have a cap, it's already done for us. If you don't have a cap, you have to follow this. It's called 10-20 system is what people follow
Yeah,
in
10-20 system.
and
Fine.
10-10 if you have more than 64 channels.
So we
And
use
they are
10-20, right?
we use 10-20. And
33
then
genes.
nomenclatures, you already know FP, what does it stand for?
Front point.
Frontopolar,
Yeah.
frontal,
Temporal,
temporal,
central.
central, sorry,
Then,
parietal.
when we were actually placing those electrodes, that time you mentioned there is a one electrode we put in the at the center of the forehead somewhere, in the line of this. Maybe that is reference or ground. I don't remember.
No, so
So
that is to align the cap. So if you
okay.
want to know where exactly to put the cap, generally take the distance from
Yes.
nasine
Yeah.
bone to this, right? Something like that. You guys, Nitesh will know better about that. He's done it more. And there are, in particular cap, it will be mentioned how exactly to measure it so that everything is in the right place. And then this basically means that your forehead is or head is divided into 10%, 20% like that. And then these are located like, in those ratios. So if this is 10%, this is 20% like that. These areas are, generally basic brain characterization. There's prefrontal area, frontal area, temporal regions. These are just basic brain areas. Occipital is at the behind, at the, posterior part of the brain. So these are related to the how we define the anatomy of the brain. So it's not random and it's not only for EEG. It is true for a brain anatomy. So even when we are talking about functional MRI data, we will talk about occipital, parietal, central, like that. And then you have these midline positions. They will have Z marked there, right? CZ, PZ. This is the center line. So just need to know that. And then there are this concept of odd numbers. Odd numbers are there in the left hemisphere. Even numbers are there in right hemisphere. Z means center. So these things you need to know. Ground electrode says it can be on the forehead, earlobe, or the mastoid, which is here. Reference electrodes typically placed on regions. So this is your homework, right? You will both figure out how many reference electrodes you have. Where is it? Where is the ground if you have a ground? If you don't have a ground, is it mentioned somewhere in your cap that you don't have a ground? So both of you figure that out for your setups. Okay, and Vicky, you can do it for all three types of cap that we have. We have the RNet cap, we have the MR compatible sleep cap, and we have a loose electrode system. Loose wale system may we can decide, right? We can decide
Okay.
where we want to place it.
So I need to check the ground actually electrode. Where is it?
Yeah, check the in the caps that we have with fixed electrodes, where is the ground and where is the reference?
So how do I know that which one
Figure
is
out,
ground?
ask Nitesh, ask this
Okay.
guy Rahul, or check the brochure of the cap. Figure it out.
Okay.
Yeah.
Ma'am, what about the muse band?
Yeah, you figure it out. You read about the Muse band, which model you have. Try to read on the brochure. It'll have a brochure. So because there are
Okay,
also
ma'am.
different types of Muse bands, right? There are different
Yeah,
versions.
yeah.
So you have
Yes,
to
ma'am.
figure out which one you used. Find their website. They will have a brochure. If you don't have a brochure, it will be there in your lab. It should have come with the
Hmm.
equipment. Yeah, and then
Yes.
they'll have. It is important. You have to, when you're publishing, you have to mention if it had one reference electrode or three, or so if you have more than one reference, what will happen is you'll take the signal from this, average these three, and then subtract. Okay. You don't have to do it. It's the device is doing that for you, but you have to know what the device is doing.
Okay, ma'am.
Yeah. So generally in this case, I had seen that they were taking three references, which means they were taking signals from these three and subtracting. So whenever you have AF7 signal, it naturally means AF7 signal minus signals of these three averaged out. So you need to know that if we have to mention it in the paper. Okay. So what's the next thing that we do after we have placed the electrode on a person? Have you heard something called impedance check?
Yes, ma'am. Impedance.
क्या होता है impedance?
Ma'am, it is like there may be some barrier in the electrical signals. So we
So
try to check.
that is a definition of resistance. When you're trying to flow current through a medium, what is the barrier it faces? So it is basically related to the voltage and the current. If you pass a current I and you measure the voltage difference V, so resistance is V equal to IR, so R equal to V upon I, voltage difference divided by current. So that is a basic definition of resistance. But when we talk about AC system, not DC system, AC system, alternate current system, we talk about impedance because it is also related to the frequency at which current is flowing. But the concept is very similar. You pass a certain current and you measure the voltage and then you divide them with each other, and then what you get is the impedance. Okay, so if you have high impedance, it basically means the quality of signal is poor. And what is causing this impedance? It is caused by several things, right? It's basically your skin is causing the impedance, the resistance or obstacle in the flow of current, the body tissues, the electrode itself will have some impedance. So it's a combination of all of this which causes the impedance. And what your EEG device is doing under the hood, you don't know about it. What it is doing, it is giving some current and it is measuring the voltage across that particular electrode. Again, the same thing. And it is dividing that and telling you that this is the impedance. So it is actually transferring some current. That is how it's measuring that. Now, if you have high impedance, it basically means that there's more resistance to flow. So then the voltage you will measure is going to be lousy or bad. So you want to minimize it. Right? So how do we minimize it?
Ma'am, we have to again set those electrodes.
So we do gel, right? We do gelling. We apply gel between electrode material and the head material so that kind of helps with the conduction and reduce the resistance. That's one thing that we do. In saline electrode, we put more water, salt
Yes,
water
more water.
solution. So we use this extra help to reduce the impedance. So if you have a gel cap, you'll do the gel better. You'll remove the hair more. All of that you can do, right? Sometimes people will also wipe the scalp with alcohol so that if there's oil in your scalp, that also needs to get removed. All of this is done to reduce the impedance, which is very important. If you have impedance, one problem is that signal from that particular electrode is going to be bad. The other problem is if you have different impedance across different electrodes, that's also going to create more problem. Okay, so we want to maintain similar range for all the electrodes, and then we want to keep it minimum. So now ideal range that you will see in paper, now it's measured in kilo ohms. Impedance is measured in kilo ohms. So if it's 5 and below, that is perfect. That is ideal. But that is typically attained in active electrodes, very easy. Most of the active systems will have that. In passive system, gel-based systems, if you've done really good job and people didn't have a lot of hair, maybe then. Less than 20 you can publish in most papers, most journals you can publish. For passive RNet, 20 to 50 is
Yeah.
okay.
He
We can
was
manage.
continuously saying for this as 50 is fine.
Yeah. So 20 to 50 is not so good, but we can do. Generally, I discard any electrode that has more than 30. And if I'm doing an EEG experiment, one or two above 30 is fine, right? But don't have like everything is 30 to 50, then don't do it. Like I want to
We
bring
have the
everything.
option, I think, there, so we can set the range like till
You
50.
set the
So it
range and
on.
ensure most of your electrodes are within the range. Sometimes one or two would be very notorious that doesn't come down. So what to do? But you have to ensure your ground and reference are low so that everyone else is low. That is going to be very, very
Okay,
important.
so they are related with
Because you're
ground and
doing
reference.
subtraction, right? So if your
Yeah.
ground itself is high, then the resistance overall is going to be high. So both ground and reference ensure that they are low first. And in general, they have a different, if you click on your software, you'll see ground and reference are set first and you set them to much lower limits. Otherwise, all the electrodes are going to be off because you're doing a difference now. So
Yes,
if it's high here and you're taking a difference between this and this, so this high is going to contribute to the overall highness. So ensure that those are low. Okay. So that is most of the stuff that you need to know as per the CAP is concerned. I think this is more than what people teach online, and more than enough for our cases comforts. The important thing is to actually check your systems and see what it is at. What are the references? What are the grounds? This is to help you do your setup better, like you understand broad concept behind it. So you will be more motivated to understand what is the impedance of the ground, what is the impedance of the reference, where is it located, and all of that. Once you are set, so you position the ground reference, other electrodes, then we can move on to the recording. Okay, this part both of you have seen. When you are recording EEG, what you're getting, like I told you, is the voltage difference between any electrode minus the reference electrode. The ground gets cancelled out. So you're getting that for all the electrodes. And what you're measuring is generally in microvolts, right? It is a very, very micro means 10 to the power minus 6. Generally in our household things, I think it's 220 volt, is it? 220 volt. And then what you're getting is micro. So 10 to the power minus 6 volts. That's after amplifying. So that's what you will see here on the left side when you have a EEG recording. Left side, your units are microvolts. Bottom x-axis units are time. So they'll be seconds. And what you're getting, we call it EEG signal, or you also call it continuous EEG waveform. And that is for each channel that we have, other than reference and ground, you will see a line like this, which will have the wiggles. So these are all EEG signal for all the electrodes in your system minus the ground and the reference. Okay. Sampling rate is how many samples do you measure in a second. It is done, it's hertz, the unit is hertz. It's a unit of frequency. It means numbers per second. 1 second में कितनी बार measure किया. That is what the sampling rate is. It's called sampling rate. It's called frequency. So this is important. Most of the EEG systems will be between 250 and 1000, actually go up to 2000 also. I think ours goes up to 2000. So higher end system will give you more samples per second. Smaller end system will give you less. In Shilpi's case, the paper that she had shared, it was 256 hertz. Okay, and this is how I knew that the data you have sent me is not raw data. When you have raw data, you will have one sample, you will have 256 samples per second. If you had measured 1 second data, you will have 256 rows. Okay. If you had measured 10 minutes, so 10 minutes, how many samples will you have? 10 into 60 seconds into 256. That's how many rows you will have. So 600 into 256 is how much? 1,53,600 samples for 10 minutes. And I think your paradigm, do you know how long was your paradigm? So if it was 10 minutes, 10 minute, 60 second. So that's how many rows.
Yes.
And then these many samples are present for all of these 4 channels. Okay, so that's what Shilpi's raw data would be, just as simple as that. 4 electrodes and signals at times 1,53,600 times, if that was a 10-minute data with this sampling rate. So that's why this is important. You need to
Ma'am,
know how many
sampling
times.
rate and frequency is same, right?
Yeah, it is same. Generally, we use sampling rate because frequency is also used for several other contexts.
Okay.
So you stick to sampling rate. It is the rate at which your device is collecting data. And in our case, it is not fixed. We can set something from 250 to 2000. I think the default would be 2000. Just check.
So it is
Check
like
what.
250 hertz in 1 second.
Yeah. If you say 250 hertz, it means 250 samples in 1 second.
Of okay, 250 samples.
Of measurement. So you can't be measuring. So you have to measure. The device is also a device, right? It's not like measuring continuously. It's obviously measuring at given points in time. Otherwise, you'll have infinite data. So it's measuring for every second, it's measuring 250 times or 2000 times, depending on what you've set.
For every second.
So let's say I was measuring your height. So I was measuring your height once per week. So that's like a frequency, right?
Yeah.
So if I was measuring once per week, how many times did I measure 1 per second? So you will have to do 1 per second. So 1 week is how many seconds? Like that you have to convert, right?
Ma'am, isn't it
So
too much, like in 1 second, 250 times?
so this is very important for ERP studies, because in those studies they want to see a peak which is happening within 200 300 milliseconds. So
Okay.
that's why such, and then even with our case, when we do power spectral frequency analysis, this is very nice. It gives you a handle on
So
doing the
we
frequency.
set it ourselves, or it is by default it is there?
There is a default number there that should be set already in the recorder. In our case, it will be set in the recorder. But you can change it. You have the freedom to change it. In most cases, we record at high frequency, and then after filtering we down sample it, which means कि इतना सारा जरूरत नहीं है. We don't need 2000 samples per second for most of our analysis, so we will
Okay.
down sample it, but after pre-processing. So this gives us a lot of data for pre-processing. We pre-process and then reduce the, so that the file sizes get reduced. But yeah, 2000
So
little bit of.
initially we can set it at high actually, which is 2000.
Yeah. So it is generally set at high, and then after pre-processing, because pre-processing can make use of more data, and then we downsample it and keep the downsampled data. But your raw files would be little larger because of the higher sampling rate, and then your post-processed files would be at lower frequency, or lower frequency. Okay, so now you do this. So you can basically, when you're doing this live recording, you can see this data. You can see it fluctuate with time. So what are the things that you do to ensure that you know that your device is working?
What, ma'am? Sorry, ma'am. Pardon.
If you've started the recording, you've not started the paradigm yet, but you want to ensure that your device is working. What is it that we do?
Yes, that eye blinks. We did this thing,
So
and the
we did eye
muscle
blink, right?
activities.
But
Yeah.
I found something interesting. So this you can try.
Clench.
Apparently, clenched jaw produces even so it produces an activity which is 2 to 3 times larger than the brain activity. So if you're seeing
Okay.
waveforms like this, and you ask them to clench their jaw, like this, you
Okay.
will see something which goes 3 times higher. And in most of the
Okay.
electrodes, you'll see that. So try that next time you try that. And it says usually prominent in the temporal electrode. Where are the temporal electrodes? Here, near
Yeah.
the ears. So that, and then eye blink, you already know. You ask them to blink their eyes, and you see it almost like a large V shape, uh, you ulta V
If
shape.
it's not working, it will be like a straight line, right?
Yeah,
Horizontal.
it will be like either straight or noisy or whatever, right?
So it's
It
very
will just,
difficult to know, I think, ma'am, if it is not straight, then how will I know that whether it is working or not?
yeah, that's why you have to do these things.
Okay, then because of this, there will be spikes, right?
Yeah, if the spikes are not coming, something is wrong. So don't proceed then.
Okay.
And the eye spikes will be very clear in the frontal electrodes. So this FP1, FP2, that is why they're very important. You see, definitely note huge. If you're not seeing this go up to twice the size of this, then if something is wrong, and you need to contact your service provider, Aerobe. Okay. The people who do ERP studies, like I was saying, right? So the other computer is sending markers. That also
Yes,
gets
ma'am,
shown here.
markers.
Yeah, so there's something, there'll be something called marker channel.
Yes, ma'am.
Even if you don't have a computer connected, but you want to note someone's mobile blinked, and you want to take a note of exactly what time, you do
Yeah.
annotation.
That time
If
Nitesh was saying for this actually, when we recorded first pilot data, he was saying to mark for the baseline actually.
no,
And
no, no, those are
we have
already
already
marked.
said that actually, as you mentioned, it was recorded.
It's already there in the audio. So exactly at 3 minutes, they will get the notification that they can start Yog Nidra.
But if it is not recorded, then we need to mark
Then
it,
you,
right?
yeah, then you play a recording of the resting state. Then you say you want to spend 2 3 seconds in putting up the other recording. So then you can say mark, and then mark, and then this is where Yog Nidra started. See, the thing is ki when you say Yog Nidra started, it is not like everyone is going to do something synchronously and Yog Nidra
Yeah.
started and they immediately went into some kind of samadhi. It's not happening, right? They're doing some
Yes,
slow,
ma'am.
gradual thing. So that exact sharp point is not needed for our type of analysis, but it is definitely needed in ERP type of analysis, because they want to know exactly 200 milliseconds after they saw the picture what happened. That's what
Yes,
they
ma'am.
want to know. So anyway, so the markers can be sent automatically from the other computer, and the markers come with a code that you will preset in the paradigm that you create using PsychoPy or E prime. So let's say you want to call positive pictures PP. So every time the PP is shown in the other computer, this line will show up, and here you will see PP written. Okay, and it will get collected with the EEG data. So later on, you don't have to worry about kab kya dikhaya tha. It's just going in the data. So anyways, we'll not
E-Prime software is used to actually visualize this, I think, data.
not visualize, create these markers systematically and
Okay.
send it to EEG. So this particular, the other PC that we have here you will be running E prime or PsychoPy, and there is a serial cable that sends signal to this recorder also. In our case, it sends it to the BUA. This goes to the same BUA, and both the data get sent to the recorder. So E prime is the thing that presents the, like, it's like Pebble, but it also sends the marker to the EEG setup. So that's what's important for ERP studies. Both of you not doing it right now, so we can, we don't have to spend a lot of
Actually, in
time
that
with it.
Gayatri Mantra study, he needs that, I think, E-Prime.
Yeah, he needs that. So he cannot do it without, right? Every time someone is seeing positive, you can't be fast enough to send a marker in 200 milliseconds. So it's not possible to do that. So that, and then after you have done all of this, you've done the testing, you've ensured that even then you just ensure that the annotation is coming. If you're clicking annotate, it's coming in here and getting recorded. Ensure all of that. Then you record a baseline. In our case, our audio paradigm already says start resting state now. So they will start resting state, but it is good to record resting state. And ideally, you should do it for at least 2.5 minutes. If you're doing spectral analysis for your paradigm, it's good to have a resting state, which is at least 2.5 minutes. You can do more, not less. But don't do it too long also. Otherwise, people will fall asleep in the resting state, and then they will not be paying attention
And
to your.
sometimes people record it like baseline data. It should be sometimes people record equal to the intervention timing. So that,
Then they are using that baseline as an active control.
okay.
In your case, you already have a control, which
Because
is
in
the,
one of the studies recently published by AIMS Delhi on the Yog Nidra, they have
yeah.
they had 90 participants and no, sorry, 20 participants about. They recorded their EEG data for 90 minutes. Uh, just lying quietly in the Shavasana. And after that, in the second visit, when the participants came, they randomized into two groups. The first group actually practiced 30 minutes Yog Nidra, and rest of the times means about 60 minutes left, because 30 plus 16 equals to 90. So 30 minutes practice Yog Nidra, and 60 minutes lying quietly in Shavasana. And the other control group, just they did for 90 minutes the same Shavasana. So that worked. I think they in that paradigm, it was like the first visit, the 90-minute recording served as a control for them, as a baseline data.
So that's a lousy control, right? Your control is better. Your control is better, because you can always argue ki if people are listening to at least something, their mind will wander less, and in resting you just completely let them be, right? So their mind will go more into thinking mode, and so that's a study design thing. It's nothing to do with EEG. It's, you could be doing fMRI and having a control group, which is just rest. That is the most basic, like you want to do something better and you want to control for the activity of the brain, which is common in two activities, but you want to argue that Yog Nidra is doing something extra special. So it will be harder to argue in their case, because anyways you're given some activity, and the other case you're not giving any activity. There'll be a difference anyways, right?
That
Even
is
then it is
passive
better.
control.
But
Yeah.
here what I'm saying is it's good to have a baseline, even if you have some other control. Like in your case, you have an audiobook, even then have a baseline, which is how we have designed it also, 2.5 minutes, right? It's always good to have, because it helps with multiple things and also helps with the analysis. So just do 2.5 minutes of this, irrespective of your control, do it. Also, people will move a little bit when they're starting. Couple of minutes, they'll probably continue moving. So all of that can go in the baseline recording and not in the actual paradigm. Okay, so This we've already talked about. So this is what the data look like to me. There are 4 electrodes that they are measuring, and the reference is all 3. So they are taking average between these two.
This is for the Muse band. Only 4 electrodes are there as per 1020 system.
Exactly. That's also in 1020 system, but only 4
So
electrodes.
1020 basically tells the actually difference, the distance between the electrodes, right? The percentage.
Distance between the electrodes, yes. So if there's 10% distance between the two, then 20% between these two, 20% between these two, 20%. You can see, right?
So actually it is already set in the cap. We don't need to do anything with this.
You don't have to do anything.
Yeah.
If you're not using a cap or a cap fabric, then
then-
it's very hard. Then you have to measure and do no one wants to do that.
Yeah.
But yeah, you can see, right? यहाँ पे 10% difference, 10%, 10%, and 20%, 20%, and again
So
10%.
1010 is much better than 1020, right, ma'am?
No, 1010 is used if you have more number of electrodes.
Okay.
So if you have 128 or 256 channels, then it is used because you want to occupy all of this space also. But it is not, see, two neighboring electrode don't give you too much extra information. So don't have to go that dense generally for most cases. Like 32 or 64 is more than enough. 64 is very, very good. So she has 4. That's her system. We can look at the data later. So now we understand this much. Kuch question, any doubt? No? So now you understand all of this. You understand frequency, right? So one thing that people will keep talking about is signal frequency. This is very important. If you don't understand signal frequency, signal amplitude, signal phase, these 3 are very important. So we'll delve into that a little bit more deeply so that you really, really understand it. So I want to start by frequency. Frequency already I explained it to you, right? What is it?
It is sampling rate.
Yeah, but generally frequency is a very, very common thing. So time is a common thing, right?
Yeah.
Time. When we say time, we mean something. So when we say frequency, it means number of
Repetition.
times per second. So you can have, let's say someone is doing jumping, right? You can have a frequency of jumping 2 times per second or half a times per second, which means 1 time in every 2 seconds. So everything, frequency is a very, very general mathematical concept. It just means number of cycles or number of times per second. It is everywhere. It is not just related to EEG. It is related to anything which has cycles.
Repetition.
Or repetitions, exactly. When you're doing pranayam, you will have number of times. Let's forget per second, it's too small. You will have per minute. You have breathe 15 times per minute. So frequency of our breathing is 15 times per minute, which means 15 by 60 per second. So 1/4 per second. Then similarly, your respiration, your heart rate has a frequency, which is 72 per minute. So it's 72 by 60 per seconds. So it's 1.2 per seconds. That's the frequency, 1.2 per seconds. We are doing 1.2. So frequency is a very, very common thing. And then when we do it per second, we call it hertz. Okay. Rhythmic repetitive activity. So when you look at EEG data, sometimes in some stages of the consciousness, you will see that the frequency is very rhythmic, which means all the electrodes are broadly showing similar behavior, which happens during deep sleep. So what will you see? If you took 1 second data, you will see 1 cycle or 2 cycle. So when we say cycle in this case, just imagine peaks. How many peaks are you seeing per second? So if someone is deep sleep in deep sleep, they will have less than 4 cycles per second. Okay, and in all the electrodes. Okay.
So it is actually, for example, like we have so many electrodes on the scalp, and for each electrode there can be these 5 waves, right? So each electrode has these 5 waves, means one of them at least. It can be delta or either the theta, alpha, beta, gamma,
or a mixture in most cases. So when we say rhythmic EEG, when we say rhythmic, it's so generally in awake state, everything will be a mixture of 4 types of all these 4, right? It can be a mixture also. It can be just a mixture of all of this. But when you have pure, something looks like just delta. That will happen in deep sleep. You will only see 4 per second.
For
Um,
all signals, for
for
all
all
electrons.
for all electrodes. That's how it's immediately clear that the person is deep sleep. But what
Okay.
happens in when you do meditation studies, it's not pure. It is a combination. It will look more like this. And
Okay. So how can we
sometimes
define that person is an alpha state or beta state then?
so sometimes it will be like this, sometimes it will be like this, sometimes it will be a sum of these two. So it's very hard. So that's why we
Okay.
talk about power. How much
Okay.
power in alpha and how much power in delta. And so I will explain
Spectral
power.
analysis, something. Yeah.
Exactly. So for most of the other state, we want to tell difference between दोनों जगे हुए हैं, right? In listening to audiobook and they're doing yog nidra, they're both awake. And visually I can't tell because it's not delta versus alpha, but it is something looking like this, then something looking like this, and I can't really tell. So we do a power spectral analysis and we want to understand how much power in all of these. But before that, so if you had rhythmic activity, then both of you should be very clear on what are we meaning when we say delta or what is frequency. You just count number of peaks per second, and if it is staying the same throughout the time, then you say it's delta. If
So
it's
frequency of wave equals to a number of peaks in a second.
exact.
Okay.
Okay, so that is very important. And then depending on how many numbers, so all these delta, theta, alpha, beta, gamma, these are very important for a biological brain. Most species will show all of these frequencies. So it's something that is natural to our brains. That is why these frequencies are important.
So then by looking at the signals, we cannot actually tell that whether it is delta or we cannot even count it.
So if you say take a human and you are seeing something at 200 beats per second, you will say that it's not human, right? It's an alien, or something is wrong with the machine. So
Okay.
these are very biological important frequencies. Not only are they important, they're also important in segregating people in different states. So deep sleep looks little different. If someone is eye open and thinking, you will see more between 13 to 30. And you can immediately ask them to close their eyes, you will see more like 8 to 13. So you will see them, they went from beta to alpha. And if someone is in the process of sleeping, they will go slowly from beta to alpha to theta to delta. So all these will, and in sleep there's concept of NREM, NREM 1,
Yes.
NREM 2. So
Rapid
they
eye
are
movement. Yeah.
so they are very interesting. So normally what happens is when you are NREM, you're going into NREM sleep, you'll go from beta to alpha to theta. But what
Okay.
happens in NREM 1 is slowly, it's just reducing in number of waves per second. In NREM 2, there's something called K complexes and sleep spindles. Spindles are very interesting. So in
Yes.
spindles, what's happening? You will see theta, 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 and then suddenly for 30 seconds, you will see bursts of beta.
Okay.
So you will see periodically in every 1 minute or 2 minutes. I don't remember exactly when, but in 1 to 2 minutes, you will see,
So we
okay,
can
theta.
detect it actually easily by
Exactly. So
looking at
doctors can very easily tell. We can also, with some training, tell that that's what's
it.
happening. So you'll see, okay, it's going at 4 to 8 per second, and suddenly you will see for 30 seconds, then again it's going like that. So that's characteristic of NREM 2 sleep.
Okay.
So that's
Okay.
why you can tell from EEG studies very, very clearly if someone has fallen asleep, because they will go from this N1, N2, and then delta. But if someone is a Mahan Yogi and then they show you that, okay, I was in beta and then I'm suddenly in delta, I didn't go through
Delta.
all of that stages, and then somehow and also maintains an awareness, we will call them very, very special. That is why we
Okay.
do these studies, that you want to see if people are capable of bypassing that, sleep route, and they go into a different kind of brain state. So that's why these studies are very, very interesting.
Ma'am,
Uh,
I have always confusion with this alpha state. We are saying that it is awake state. So now
yeah.
it means we are in alpha. But when we do yoga nidra, people expect that person will go in the alpha state again. That's
No,
what
no,
does it mean?
no. So alpha is so given. So the moment you close your eyes, you will see alpha.
Okay. Because
If
Rahul sir mentioned this thing that you will able to see alpha when they practice
huh,
yoga nidra.
and that you will be able to see when their eyes closed also. But if they go into deep meditation and if you're not seeing those bursts of beta, but only theta, you will say maybe it's a deep meditative state, because they are not showing sign of sleep, but they're showing signs of brain slowing down. That's very important, right? So theta is very
So
important.
person, when the person starts yoga nidra, actually it can be in the beta state or alpha state. We do not know.
Yeah, it will be a mixture. In most cases, things are just mixtures. it's a mixture. So we talk about in terms of powers. It's not going to be a pure alpha or pure beta. It will be a composition of this. And then slowly you will see that alpha is decreasing and theta is increasing. And if your theta increased and you didn't see any sleep spindles, then you will say that it is a deeply relaxed state. They are not sleeping. That's as good as it gets. And you will sometimes get some power in delta also, which means कि pure delta तो हमको कभी नहीं दिखाया अभी तक. But what is happening is some component of delta is also, so power in delta band is increasing. So we call them bands because they are not one frequency, they are a range of frequencies, like a band between this and this. That's why they're called bands. And so what I'm saying is rhythmic is rare. Rhythmic is happening in very peculiar states. So in deep sleep, rhythmic is happening, which is one pure frequency. Everything is going coma probably happening. Arrhythmic is most normal, which means ki there's no one stable rhythm. There's a combination of things going on together. Dysrhythmic is it happens in epilepsy, or some very weird spikes will happen. So those are patient groups, not seen in healthy people. So those are used for characterizing things like temporal lobe epilepsy or other epilepsy, those kinds of things. So diagnostic things. We don't get into that. So we will be mostly dealing with arrhythmic or rhythmic. Rhythmic typically happens in deep sleep, but you can imagine them happening in deep meditative or samadhi kind of states also. So idea is the brain might be slowing down, or in some cases you see more awakening also, right? So you see more, maybe if they're having some kind of kundalini experience, maybe they will get more aroused. So this gamma is also pretty rare. 30 and above is very rare. It happens, people say, when someone is solving a some maths ka problem, difficult problem, and just at the moment they solved it, they will see some, bursts of high frequency waves called gamma. But most people are not able to sustain it. But there's a very, very popular study, which is a very well cited study of Tibetan Buddhist monks. There were 6 monks, all with more than 40 years of practice. They were able to sustain their gamma for throughout the experiment. So they were all in like gamma state, which is very interesting, which was very hard to believe. And they did a lot of, digging, but that's the study. The Buddhist monks were like constantly in gamma, which is very rare for normal people.
So gamma is actually basically unhealthy, right, ma'am?
No, not gamma is not unhealthy. A continuous rhythmic gamma is very rare, and it happens in monks. For most people, gamma will happen when you have solved a problem, difficult problem, or you felt like really, really good, and suddenly you were like, wow, I'm feeling very good. And then that maybe burst of gamma will happen, which means it will last for 30 seconds or so. That is more common in normal people. But in those monks, so you're getting confused between dysrhythmic. Dysrhythmic is spikes at different weird places in brain. Let's forget about that. That is pathology. We're not talking about that. We are saying
Actually, I
if
was
some
under the impression that the frequency is high means there is a problem. Means it
no,
indicates an
see,
unhealthy state.
that's the funny thing, right? In yogic texts also, when you're talking about arousal, when you
Yeah.
talk about heightened state, it may not be a deep sleep like state in Yog Nidra. It could be a very, very heightened. What happens after Bhastrika? You feel very alive. So
Yes.
I don't expect that everything will go through this route of, beta, then alpha, then theta, then delta, but it can
That's
also
what I
go
used to think.
and
That with
that is a
yogic
misconception.
practices, so we want that the person must have the delta state.
No. In fact, I think a lot of people have very high energy when they do yogic practices. In fact, such high energy, they're not able to sit and they want to do more work, and they will be very like doing a lot of work for benefit of society. And I think they will not be necessarily in delta. I don't know. These are all hypotheses,
So
but I'm
they how
telling
can these waves then tell the person's mental state that whether it is calm or relaxed? Because the gamma you were saying that it is normal and it is found in monks as well. So how can we say the person?
gamma is not normal. Gamma is very rare in normal people. It is normal in monks who have done 40 years of sadhana. They are monks who practice so much meditation. So now the problem becomes, see, that's what research is, right? You can't answer everything with one study.
Yes.
First study will show this is happening. We didn't know that this happens. We didn't know. They were the first people to show normal people with so much gamma activity. No one had seen that before. So initially their reaction was, okay, maybe our equipment is faulty. So then you want to change the equipment and see if it's happening with other equipment. Then you were thinking, okay, maybe they are moving too much or they're doing something really funny, which we don't know why they are getting this. So you observe them, you see their motion. Are they moving too much? What is happening? So do you try to repeat that experiment? One study by itself cannot establish something as groundbreaking as that. So a lot of extra new studies need to happen to reinforce that. So we need to do that. But gamma itself is associated with, they call it eureka moment. When you solved something, eureka, like you like, whoa, I got it. So that's when it comes. And it comes for very small period for normal people. So then that study was really groundbreaking
So it
that way.
is basically type of excitement. There is high energies there.
I don't know. You can call it intuition. You
Yeah,
can call it. We don't know. There's not enough research, right? It can also happen when you're feeling oneness with everything. I'm not sure. So then of course you can interview the participants and ask. We are seeing a lot of gamma. What is it that you were feeling? So we did one pilot with this guy. One old guy has done Vipassana for several years. So he was saying that I feel like I was in a state of samadhi. I was mostly focused on he was doing Vipassana and he was mostly focused on his Sahasrara. But
okay.
we didn't see delta, we saw gamma for that person. So you figure out, you do interview. That's what called neurophenomenology. So you get something interesting. And now imagine one person who is saying कि मैं समाधि में हूँ, and what you're seeing is same as everyone else, alpha, beta. And we're like, how do you know that you are in samadhi? So your brain is not going to lie, right? If you're truly in a very deep state, it will show up, especially if it's a very coherent state across your being has changed and your mannerism has changed, and you're saying that I'm really realized and I can know the truth and I can be very quiet, and all that he's saying and nothing changing. It's like someone is saying, I'm physically very, very strong, and you ask them to lift 20 kgs, they are not able to. Then how will you believe that person? So that's why it's important. But and then you see something funny, you see something new, you've not seen that before, then you have to ask that person how is it that they're feeling, and then you start moving that research forward, that maybe these Buddhist monks, they will generally say that we are in a state of high vibration, we are in a state of loving kindness, and we are able to maintain that, people say in a high frequency state. So gamma is also common, should be common in long-term meditators. So don't be fixated that it will go in delta, it can also go the other way around. Okay, so these are all hypotheses. I'm not going to make a comment on that. I'm just telling you that the concepts are these. Using these tools, you need to figure out what is happening in your study. Okay, so frequency, I've told you. Frequency, you understand, right?
Yeah, ma'am, before moving on, I just want to reconfirm the concept. Like initially we discussed about the frequency or the sampling rate actually. So you mentioned it for every second, 250 samples of measurement. That's what the highest. So in frequency of wave, number of peaks in a second. So it is, which means in the one sample, like for every second there were 250 samples. So in one sample, it has the number of peaks in a second, right? That's what we are measuring in the frequency of wave.
So yeah, so if you had 1 second data, you had 250 samples. So it measured here, everywhere. You had 250 samples here, and when you plotted them, you only saw 2 peaks, which means the delta.
Okay, because that 250 samples, that was per second, means every second there were 250 samples. So in and this is, we are in frequency of wave, we are talking about the number of peaks in a second. Okay, so in one sample, there are the number of peaks is frequency of wave. That's what we are saying.
Yeah.
In one
Yes.
sample.
Yes. Yes.
Very
But
complicated.
you can imagine that this curve here is made of 250 data points. If you had collected this, so there's a dot here. This is when you measured the data. That's called
So
sampling
it is
rate.
for the 1 second, it is visible.
If I only took measurement for 1 second, I will have data at 0.00 whatever 6, and then like that. So many data, I'll have 250 data that will make up this curve. And then when I visually see it, I see 1 or 2 peaks. So I'll tell, okay, this is what the frequency is around 2.
So this is one sample actually.
No, this is 250 samples. In 1 second, you have 250 samples.
Okay, this is 250 sample.
250 or more, whatever. You can't make a peak pura detailed this thing in one sample, no?
But
One
in
sample.
but if it is 250 samples, then how can we say that in each now it has the number of peaks in a second? Because this is very difficult. Yeah.
So imagine you take data at, you said you take 10 data points.
Okay.
Okay, let's do that. You took so I took measurements at all of these points between 0 and 1 seconds. I took measurements at 0 seconds, 0.01 seconds, 0.02 seconds. So this is time. इतने बार मैंने measure किया. So my sampling rate is 100. 100 times I measured in a second. Then you
Are you
measure.
showing something?
Oh, you can't see kya?
No.
Okay, wait.
Yes. It's
So I'm saying if I took measurement at all these points between 0 and 1 seconds, I will take one data measurement. I will not take it. The amplifier will take a measurement at 0 seconds, 0.01 seconds, 0.02 seconds, and so on and so forth at up until 1 second. So my sampling rate becomes 100. So in time, you have data for all of these points, and then you have something like a signal. What are you measuring in time? You're measuring signal in time, no?
yes,
Then you
ma'am.
plot signal versus time. So for all of these, you have some value of signal.
Okay.
So when you plot the signal, you see something like that. Something that I was showing in the. Oh, you can still see my screen, is it?
Yes.
So when you plot it, so you plotted from here to here, you had hundreds of samples. Then you plotted the signal versus time. And then you are seeing, I'm seeing a peak here and a peak here. So it's two peaks. So out of the 100 samples that I had taken, I'm seeing two peaks only. So my frequency is 2.
Okay.
Yeah, so दो अलग-अलग चीजें, you're getting confused. Sampling rate is how many times did you measure? You have to measure more number of times in a second, many number of times. You can measure
Yes,
2000 numbers of times. But what are you measuring? You're measuring signal.
yes, ma'am.
When you
Number
plot
of
signal
peaks.
versus
Yeah.
time, you can see, you cannot see 250 data में 250 peaks. That makes no sense. हर डेटा पे peak थोड़ी दिखेगा, तो वो तो so you will see some peaks, and you will hopefully see somewhere between 0 to 40, 50 peaks per second. That is your frequency in the observed data, frequency of the
Okay.
signal. आया समझ?
Yes, ma'am.
तो जब ये डेटा दिखा रहा होता है, यहाँ पे 0 से 1 सेकेंड में बहुत सारे सैंपल्स होते हैं, उसको वो प्लॉट कर रहा होता है लाइव आपके लिए. एंड देन व्हेन यू आर सीइंग इट लाइव, यू टेक अ 1 सेकेंड का स्लाइस एंड सी उसमें कितने पीक्स दिख रहा है रफली. But you are able to do it because you have too many data. You have so many data, you are able to plot and see. ठीक है? तो that is what it is. So whenever we are talking about now frequencies, sampling rate को भूल जाओ, उतने बार वो calculate हुआ, तो raw data में उतना सारा data दिखेगा हर channel के लिए. उसके बाद हम हर चैनल के सिग्नल को प्लॉट करेंगे टाइम के साथ, which is what raw data means, and then हमको उसमें कितने पीक्स दिखे, वो that becomes the signal frequency. Okay? मतलब you can think more about it. हो सकता है कि भी के लिए ज्यादा हो गया. I can stop here also, and then we'll do the
Yes,
ampli.
ma'am.
है ना? We can think about frequency, watch more videos, think about signal frequency, and then next time we'll cover the amplitude and phase.
Okay. Signal.
Now do it on notebook also so that you understand the maths.
Yeah.
ठीक है? but थोड़ा थोड़ा maths तो चाहिए होगा ना, otherwise you can't be confident ever. So little bit of maths is required. ज्यादा नहीं, little bit you have to understand. ठीक है. So
I
अपन
have one image. Can you just confirm by what it is telling? Actually, I understand by that image. Actually, it is telling the bipolar thing. What you just explained. So I'm just sharing the screen.
okay.
This is I prepared notes from that Udemy thing. Hope it is visible now.
Yeah.
So like they have mentioned here, pairs
Huh.
F7, T3. So it is bipolar, right?
Yeah, it is bipolar. Exactly. That is the definition of bipolar. So they are taking two electrode pairs, and
Yes.
they're using, for each electrode, they're using a different reference from
And
the
we call it tracing, right? These signals,
yeah. So
waveforms.
they do it for very specific regions. We don't need to do that. We generally do monopolar.
Okay,
They're
means
just
single
done for
electron.
different diseases. So some people, yeah, this is done for generally medical doctors will do it for certain things. They have a very specific.
So the two actually the electrodes they're related with each other, or they are just different.
No,
Means
they're different. Each, so basically, you have to think about the reference is different for each electrode.
difference.
इसका
Okay,
रेफरेंस यहाँ है, इसका रेफरेंस यहाँ है, इसका रेफरेंस यहाँ, it could be like that, or it could be like this. इसका रेफरेंस यहाँ है, इसका रेफरेंस यहाँ है, इसका रेफरेंस यहाँ है, like that.
okay.
So there are good reasons to do that, but we don't need to worry about that. We generally
It is
deal with
just
monopolar.
monopolar.
We have one reference, and every electrode's reference is that same thing.
Okay. See.
Yeah, so we'll stop here. Next time we'll do the Fourier transform thing. Try to read more on frequency, try and understand, try to, even in R, you can start thinking about sampling rate. Sampling rate, कितने samples दिए मैंने अगर क्या बोलते, जैसे you're breathing at a certain cycle, right? You're breathing at 15
Yes, ma'am.
15 per minute,
15
right?
to 14 to basically 18
15
respiration.
per, so and then so similarly you can imagine blood pressure. Your blood pressure, I'm measuring every second. If I can't measure every second, it's every 2 minutes I measure your blood pressure, and I
Okay.
plot your blood pressure versus time.
Okay.
ठीक है, and I want to see 1 घंटे में कितनी बार ऊपर नीचे हो रहा है.
Okay.
So that peak is the peak of blood pressure versus time. 1 घंटे में से 5 बार ऊपर नीचे हो रहा है एक नॉर्मल हेल्दी लोगों का, बट कोई तो अनहेल्दी है उसकी बार बार ऊपर नीचे हो रहा है, 50 बार ऊपर नीचे हो रहा है.
Okay.
So कितनी बार मैंने मेजर किया, दैट हैज टू बी मोर देन द एक्सपेक्टेड नंबर ऑफ पीक्स. मतलब वो ज्यादा बार तुमको लेना चाहिए, तभी तो तुमको पता लगेगा, तुम देख पाओगे कि पीक्स आ रही है
Yes,
कि नहीं.
ma'am.
मैंने हर मिनट में ब्लड प्रेशर ले लिया किसी 50 लोगों का, और कुछ लोगों का मुझे दिखा कि 1 घंटे में 2 ही पीक्स हैं, और कुछ लोगों का मुझे दिखा 4 पीक्स हैं. तो एक तो सिग्नल फ्रीक्वेंसी की बात हो रही है,
Yes,
और
ma'am.
दूसरी मेजरमेंट की बात हो रही है. बाय डिजाइन आप जितनी पीक्स एक्सपेक्ट करते हो उस पर्टिकुलर बायोलॉजी में, उससे
Yes, ma'am.
ज्यादा बार आप डेटा कैप्चर करोगे, तभी वो प्लॉट करोगे तो पीक दिखेगा. अगर मैंने घंटे में 2 मेजरमेंट लिया है तो मुझे कैसे पता होगा कि पीक बना कि नहीं बना? वो तो 2 डेटा ब्लॉब की तरह दिखेगा, एक यहाँ दिखेगा, एक यहाँ, दोनों के बीच में लाइन बना दिया, क्या पता लगा? कुछ ना पता लगा. अगर मैंने 4 डेटा लिया तो हो सकता है ऐसे 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 दिखे, बट अगर मैं
Okay.
500
We have
डेटा.
enough number of observations in order to tell the number of peaks. That's what.
Exactly. So that is what in EEG you take at least 250 per second so that you can tell 5 peaks बन रहा है, 20 peaks बन रहा है. You're not limited by that.
Okay.
ठीक है, बट फ्रीक्वेंसी बहुत इंपॉर्टेंट है. फ्रीक्वेंसी नहीं समझ आए तो अभी तक, मतलब दैट इज द हार्ट ऑफ ऑल ऑफ इट. और आ जाएगा, इतनी कुछ नहीं है. तो then that is relevant to everything in any kind of signal. It is not EEG signal, it is all signals will be talked. Whenever you're talking about a signal मतलब something that changes in time.
Yes, ma'am.
Even if you're doing height measurement for a kid, that is also a signal changing with time. It will not have peaks and it doesn't go down, it only goes up, right? And then it goes up,
Yeah.
and then
Yes, sir.
it becomes stable. But let's say I measure weight, it will fluctuate, it will go up, it will go down, it will do whatever, up, down, up, down, up, down, right? Like that. So anything is signal if it's measured in time. How many times you measure it in a second is called sampling frequency. How many times do you see it go clearly up and clearly down? That's generally characterized as a peak. We call it sinusoid, and then we talk about its frequency, and that becomes very meaningful. Even when you throw a पत्थर in पानी, right? पानी में पत्थर फेंकते तो waves बनती है ना. तो आप बता सकते हो 1 मीटर में कितनी वेव बनी.
Yes,
देख के बता सकते हो चार रिपल बना या 5 रिपल बना. So that's
yes,
like a Fourier transform. You have to do Fourier transform of height of water surface to tell कितनी waves बनी. But आंख से देख के बता सकते हो ना 4 बन रही है. So
yes.
it's whenever something is going rhythmically up and down, we talk about its frequency and कितनी बार 1 मिनट में ऊपर नीचे गया या 10 घंटे में ऊपर नीचे गया, something like that. The cycles. ठीक
Okay,
है.
ma'am. I think it's enough for today.
हाँ, I
We
think
have to digest it.
हाँ, 1 hour is generally enough.
Yeah.
And then we'll do more practicals also next time.
Thank you very much, ma'am, for it.
Thank you. Bye.